All right, here's a little bit of help on how to find the force of friction between your shoe and the surface using the spring. Good news, we've used these before, so hopefully you guys feel somewhat confident with it. But what you're going to do is you're going to drag your shoe across a surface. You can see I'm doing mine on like a rubbery matte surface that you put in kitchen cabinets. Irrelevant, but whatever. And I'm going to drag it to the right. The key thing is, though, to do it with a constant velocity. This is so important because that's going to then let us know the forces are balanced in the X component because it's not accelerating, which basically in the end lets us know that the spring force pulling to the right needs to be the same but opposite direction as the frictional force to the left for them to be balanced and add up to 0. And that is the most important thing to being able to do this lab. All right, so let me show you the video of what I did real quick. Make sure you pull it horizontal, like I said in the other video. And you'll notice I tried to pull it as constant as possible, but it does jump around a little bit. So if you watch your video a few times, you'll notice where it's smooth and where it jumps. Mine actually jumped near the end, so I'm going to use the frame scrolling at the bottom to not do the end, but more the beginning. Okay, so somewhere right around there before I get near the end. Now, what I would like to do, since you can see the ruler in the background, is I would like to line up the beginning of the spring with a nice number. I'm going to pick the easiest. I'm going to line it up with 10. Because then, wherever the spring ends, which is 19, it worked out to be pretty nicely lined up with 19. The difference between those is the length of your spring when, of course, it's stretched. So take the difference, 19 minus 10 is 9. And that's going to be my new length when it's stretched. That's not exactly the displacement though, so let me switch over to Notability. I've kind of set up some work for you guys, so I hope this helps. The initial spring length when there is not a force is 2.2 centimeters. I think we're all the same, all right? This stretch spring length though is what you just determined by doing the video. So I would put in for mine 9 centimeters, which of course yours will be different, all right? What we want, though, when using Hooke's law down here is we want the displacement, which is the new length minus the original length of 2.2. So I need to take the difference between these, which again we've done, and this will actually tell me how much the spring's length has changed from when it was at rest to when it's stretched. Now, you will be able to apply this to Hooke's law, but you got to always pay attention to your units. I'm just telling you right now, these units, we got to fix them. All right, so putting a little bit of work on you guys, do your conversion, and then you can actually apply it to Hooke's law down here for displacement. The only other thing then to solve for this spring force is we need to know the spring constant, but good news, we've already done labs with this spring, and the first lab we did with it was to actually find the spring constant of it. So if you don't remember it off the top of your head, just recall that old lab, and then you'll be able to find the spring force that you're actually pulling to the right with. How does this, again, help me get the force of friction? As long as you pulled it with a constant velocity, and I know this is still kind of weird to think about, but as long as you pulled it with a constant velocity, the forces in the X component are balanced. So the spring force pulling to the right and the force of friction opposing the motion to the left are actually the same size, just opposite directions. So when you draw your FBD, those forces in the X should be balanced in terms of their size and opposite directions. And then you should set up Newton's first law. So again, I want to see those details as easy as the math is. So set up some of the forces in the X. If they are balanced, they must equal 0. So then helping you out, the force of the spring plus the force of friction equals 0. So then if you know a value for the spring force, plug it in and you'll get the frictional force. Hope this helped, guys.